This is Sparks Sustainability, and I'm Eric Sparks. With a staggering 37% of global greenhouse gas emissions, buildings and the construction industry together are one of the biggest contributors to global warming. Now, there are things called LCAs, or life cycle assessments, which calculate the total environmental impact of something. LCAs can be performed for the construction industry, but they are most often done at the end of the design process when most of the design decisions have already been made and it is essentially too late to make any significant changes. The earlier that LCAs can be done in the process, the larger the impact that it could have on the end result. The problem is that the earlier in the process it is, the less information there is to base an LCA on. So I started wondering how it might be possible to have an LCA early enough to actually matter in the design and construction process. If you haven't chosen the materials yet, how can you determine the environmental life cycle impacts? And if you have chosen the material, then it is already too late to make an impact. Might there be some way to generate an LCA before the materials have been chosen? That was the puzzle that I was determined to figure out. What I came up with is to have a separate software tool that can import some standard file types of architectural designs, such as AutoCAD. The software would have thousands or tens of thousands of finished designs for many different types of structures in its memory. Then an AI tool could be integrated to compare the designs for the new structure to the designs in its library to find the closest matches of similar structures, and then to make generalizations of the most often used materials and processes for that type of design and construction. This would provide an approximate baseline LCA of the probable impacts of the overall design based on the current standard methods and materials for that type of construction. In the initial schematic design phase, only about 15% of the total design work is done, but a large amount of the overall decisions about how the building will ultimately be constructed are made in this early phase. The phase gets the basic framework and layout of the building done, but it is prior to materials being selected. So this is the perfect time to see what the impact of this building will be if it is constructed from the most commonly used materials and methods. If a city, state, region, country could make a policy that all major types of new building construction would be required to have an LCA done for that initial schematic phase, it might be able to bring considerably more visibility to the effects that early design decisions can have on the overall environmental impact that this building will have over its lifetime. Bringing attention to the environmental impacts is definitely a good thing, but there needs to be a financial incentive to induce the architects, contractors, and clients to make significant improvements against that baseline LCA. A motivating factor for making design decisions in favor of lessening environmental impacts could be tying the LCA results to tax breaks, subsidies, grants, or other financial incentives. Perhaps a city might tie this into the fee structure for building codes and permits. Regardless of the financial incentive mechanic being employed, each project would receive a baseline LCA. And the more the results of the final LCA are improved against that baseline, the greater the financial benefit. The architect now has ample opportunity to swap out materials for lower impact replacements, as well as to utilize lower impact processes. The circular materials commodities market that I discussed in a previous episode would be a good method for finding circular materials to utilize. It could even provide the documentation to confirm the distance the different materials traveled and how much refurbishment, if any, they required. The biggest hurdle to implementing this would be the development of the LCA tool itself. Creating an LCA program that could import those design files and extrapolate to a standard LCA would be an extremely large and complex project. But the software developers I've talked to think it could be built. Considering that 37% of the world's greenhouse gas generation comes from this industry, the effort and investment would be well worth it. And once it's built, trialing it in a city would make sense to see how it goes. This kind of tool, along with the associated policies, has the potential to make a dramatic impact on the methods and materials that are used for construction. It would spur innovation and creativity by giving a financial incentive for substantially improving the sustainability of the project by reducing the overall environmental impacts of building this structure. As greenhouse gas emissions are one of the largest impacts, they are probably the most likely ones to be a major focus for reduction. But a benefit of this idea is that for each project, the focus would be on whichever impacts are the largest for that project in its initial baseline LCA. The largest impacts would be the primary issues to target to receive the financial incentives. Thanks for listening. I'm Eric Sparks. For more info or to contact me or for a text version of this article, visit sparksustainability.com.